Okay, so the last thing I want to talk about is the intermediate value theorem, which is something that you'll see next year in calculus, but that is an easy enough topic and relevant enough to this subject that we thought we'd share it with you this year and give you a little preview into what you'll be seeing next year. So the intermediate value theorem says you have A and B, and they're real numbers, and A is less than B. So I've given you this visual here where you've got a number line. I've got two different number lines here, but they're the same idea. A is less than B. Okay, and they tell us that we have a polynomial function, and f of A and f of B are of opposite signs. So remember, f of A is just a fancy way of saying what is the function value at A. So basically you've got your x value of A, and f of A says how high up or how down low that is. So if I was describing this ordered pair, it would be A, f of A, where A is the x value and f of A is whatever you get for the y value when you plug in A into the function. And f of B is of opposite signs, so I put it above the x-axis. So this is B, f of B. Okay, and since I know that I'm dealing with a polynomial function, I know that it is smooth and continuous like we talked about last class. So at some point in between A and B, my polynomial has to cross the x-axis. So I know that somewhere in between these two, it is crossing the x-axis. Okay, and the same could be true if I had, here's the x value of A, so here would be the ordered pair A, f of A, and if f of B is of opposite sign, then that would be below the x-axis. Here's B, f of B, and because this is a smooth and continuous polynomial function, I know that at some point in between, I had to cross the x-axis. So that's really all intermediate value theorem says, is you've got a polynomial and you've got f of A and f of B, and they're opposite signs. It doesn't matter which is positive and which is negative, but one has to be positive and one has to be negative. So in this first case, f of A was negative and f of B was positive. It was above the x-axis. And in this second example, f of A was positive and f of B was negative. So it doesn't matter which is positive and which is negative as long as they're opposite signs. Okay, so this first example in the notes says to use intermediate value theorem to show that the polynomial function f of x equals 3x cubed minus 10x plus 9 has a 0 on the given interval. We know that because it's a polynomial function, and I can just see just looking at this equation, it's going to be smooth and continuous. So what you want to do to use intermediate value theorem, it's really pretty easy, is just first you want to find f of A. I called it f of A just because of the way this is defined. F of A, aka f of negative 3. That's what you'll do first. And then you will find f of B, aka the second value, f of negative 2, and look at their signs. Okay, so that's all you want to do first. So f of negative 3, you have two options. You can either use synthetic substitution or direct substitution here. I just did direct substitution. We'll give you a little bit of practice with direct substitution since you've gotten a lot of practice with synthetic, but if you want to do synthetic, you can do that too. So you have to keep in mind order of operations here. You have to do negative 3 cubed first, then multiply by 3. So that would be negative 27 times 3 would be negative 81. Okay, negative 10 times negative 3 would be plus 30 plus 9 equals negative 42. Okay, so we got f of negative 3 equals negative 42. All right, and let's go down and also do f of negative 2. And again, I'm going to do direct substitution. So 3 times negative 2 cubed minus 10 times negative 2 plus 9. So, again, order of operations, you have to do exponents first. So negative 2 cubed is negative 8 times 3 is negative 24. Okay, and then negative 10 times negative 2 would be plus 20 plus 9. That gives us 5. So f of negative 2 is 5. So basically, intermediate value theorem says that since f of negative 3, we got negative 42, I'm just going to say is less than 0. It was negative. And f of negative 2, that was 5, so I'm going to say is greater than 0, positive. Then the polynomial, I'll just call it f of x, the polynomial f of x must have a 0 because it's smooth and continuous on that interval. And that interval was what was given to us from negative 3 to negative 2. This is really what we come up with applying our two answers. So not only do you have to plug in negative 3 and negative 2, you also have to explain how intermediate value theorem worked. And really it was just one of these, f of negative 3 was negative, one was positive, so I know that I have to have a 0 in between there because at some point to go from negative to positive, I have to pass through 0. That was like the visual that I gave you at the beginning. So this is really it for intermediate value theorem. So now you can attempt to do those problems in your homework assignment.